Hello everyone, this is Professor Cameron from the Wentworth Institute of Technology. And what we're going to be going over today is creating basic parts in Solidworks. Now the tutorial that we're going to follow is loosely based on Solidworks Lesson 1 parts. We're going to make some changes to suit our own needs, but the end result should be more or less the same. And this is the part we're going to be working on today, this kind of Lego brick looking piece. Now, when we model parts in SolidWorks, what we want to do is look at this shape and break it down into its base shapes, or the simple shapes that compose this object. And when we look at this, we realize this is really nothing more than a cube with a cylinder on top of it. And when we model in SolidWorks, we're going to take the same approach that we would take if we were to sculpt this part out of clay. We would probably sculpt this cube base. On top of that, we would sculpt this cylinder, go ahead and cut a hole through it, round over all the corners and make it nice and smooth. And then in this case, we go ahead and hollow this part out. And that's going to be the last operation that we do. Now, in order to make a 3D object in SolidWorks, in this case, this cube base, which we're going to cover in just a second, what we first have to do is start with a sketch of a 2D object. In our case, we're going to start with a sketch of a square. And then in SolidWorks, we're going to stretch that square up to create this 3D object. And then it's just a matter of adding and subtracting sketches to create our full shape. So to go ahead and start this, what we're going to do is we're going to go ahead and create a new part file. For this, we're going to come up to File, New, and it's going to give us 3 files to choose from: a part file, an assembly file, or a drawing file. In SolidWorks, a part file is for any one solid continuous piece. If we were to think about this like Lego bricks, a part file would be one individual Lego brick. An assembly file is a combination of 2 or more parts that we've already made. This would be like the rocket ship that we make out of Legos. And a drawing file is for our documentation. This would be the instruction sheet that comes in the box. For us, we can go ahead and select New Part File and select OK. That's going to go ahead and give us our blank workspace. Now, whenever we create a new part file, the very first thing we want to do is come down here to our bottom right-hand corner and set our units. And today, we're going to be working in millimeters, so we can choose the option here called mmgs. Now, when you work in SolidWorks, you want to set this right off the bat. You want to make this a habit, because if you run through this entire model and you realize you're in the wrong units, it's not a quick fix of just coming back and switching these units over. You actually have to scale your entire part. So we're going to select millimeters. So like I was saying earlier, what we're going to first start with is a 2D sketch of that square base. Now if we look on our left-hand side over here, we'll see that SolidWorks gives us 3 planes to do those sketches on: a front plane, a top plane, and a right-hand plane. These planes are like pieces of paper that we can create our sketches on. So what we're going to do is on our left-hand side, we're going to choose our top plane. Up in our toolbar, we have a number of tabs: Features, Sketch, Evaluate. We're going to choose the Sketch tab, and then we're going to select this first icon here. This is going to create a new 2D sketch for us. Up in our toolbar, these are our sketching tools. And if you've ever used Microsoft Paint or Photoshop, These tools work exactly the same way. You've got a line tool, circle tool, square, arc tools. From our square tool, we have a number of options. Corner, center, 3-point. We're going to choose the option called center rectangle. This is going to allow us to draw a box using the center point and one of its corners. This red arrow right here, this is our origin. This is where those three planes, our front, top, and right-hand plane, intersect. And this is a good place to anchor our sketches to. And I'll explain that in a little more detail in just a minute. But what we're going to do is we're just going to go ahead and click right on that origin and draw out this box. Now, when we draw in Solidworks, what we do is we create a rough shape of the part we want, and then we go ahead and set dimensions for it afterwards. Whenever you create a sketch, it exists in what's called an undefined or an underdefined state. Meaning this block is kind of like a big blob of jello. You can stretch it, shake it. There's nothing really holding this in any place. And this is undesirable for two reasons. One, we have no idea how big this box actually is. And two, like I said, there's nothing holding this box in any sort of shape. So what we're going to do is we're going to go ahead and add definition to this. To do that, we're going to use this tool in our toolbar. It's called Smart Dimension. This allows us to set the length of lines. What we're going to do is grab Smart Dimension and select this very top line here. We're going to go ahead and set this to 100 millimeters. What that's done is it's gone ahead and set the width of this box. The width of my box cannot change, but you'll notice the height still can. We're going to grab Smart Dimension again and set the left-hand side of this box to 100 as well. Now, you may have noticed that when you put those dimensions on, your sketch lines turned from a navy blue to black. I'm going to draw a second box to illustrate this. You guys don't need to add this. This is just for demonstration. When you first draw a sketch, it's going to start out as a navy blue sketch. That means that sketch is underdefined. Like I was talking about earlier, this box can be dragged around. When your sketch is all black, it is fully defined and it cannot change shape. Before we go ahead and extrude this or do any other work with this sketch, we need it to be fully defined. We need it to be all black so that it's not going to change shape on us. Now, I'm going to go ahead and add these same dimensions to this second box. And you'll notice, even though it has the same dimensions, it's the same shape, it's still underdefined. That's because there is nothing tying this box to any particular location. And while the shape won't change, the location can. That's why when we drew this first box, we tied it to the origin. It's going to make everything nice and tidy, and it's going to prevent this box from shifting around on us. So now we have this box here, and this is just a 2D drawing. There's no thickness to this. What we're going to do now is go ahead and stretch this up and turn it into a 3D object. To do that, we're going to go to our Features tab and select the Extruded Boss Base tool. This tool works kind of like a pasta maker or a Play-Doh extrusion machine. Whatever shape you draw, you can stretch it up as tall as you need it. On our left-hand side over here, we're going to set our height to 30 millimeters. Right now, this box is just kind of a translucent yellow. To solidify this, we can go ahead and click OK. And that's going to go ahead and solidify this and give us this 3D object. Now at this point, this would be a good time to save your model. Come up here and save this, and you can save this as whatever you feel like. When you're working in Solidworks, it's a good habit to save every 5 or 10 minutes or so. It's usually not a question of if Solidworks is going to crash on you. It's a question of when. And it has a habit of crashing right after you've done a lot of work and right before you've gotten a chance to save any of it. So make that a habit to save frequently. While we're here, now is a good time to cover how we manipulate our model in our workspace. If you're working with a mouse and you want to drag your model around, all you have to do is click and hold your center scroll wheel, and you can drag your model around like I'm doing. Zooming in and out on your scroll wheel will zoom in and out on your model. If you're working with just your keyboard, your arrow keys will drag your model, and 2 fingers on your trackpad will zoom in and out. Now, you may find that when you do this, you might lose your model, like I just did. If that happens to you, all you have to do is press your F key on your keyboard, and SolidWorks will find your model for you, no matter where it is. If you want to look at your model in what we call an isometric view, which is this sort of 3/4 3D view, Control 7 on your keyboard will do that for you. Control 7. And if you want to look straight down on a surface, all you have to do is select the surface you want to look down on and press Control 8. We call this a normal to view. So once again, F will find your model. Control 7 will put it into an isometric view. And Control 8 will put it into a normal to view. So what we can do now, if we look back at our finished model, so we can go ahead and add this cylinder on top. Now the steps we're going to use for this are pretty much the same steps that we used to create this box. We're going to create a sketch and then use the Extrude Boss Base feature. Now we know that we can create a sketch on our 3 planes. We can also select any flat surface of our model to create a sketch as well. And that's what we're going to do. We're going to select the top flat surface of this model, go to our Sketch tab, and select the Create New Sketch feature. We're going to come up and grab our Circle tool, put that right on the origin, because that origin is in the center of our box, and draw out our circle. To set the size of this, we're going to use Smart Dimension. Just click on the outside perimeter, and we can set this to a diameter of 70. Our sketch is fully defined. We can tell that because our sketch is black, and down in our status bar, it tells us it's fully defined. To extrude this, we're going to go back to our Features tab and select Extrude Boss Base. We're going to go ahead and extrude this to a height of 25 millimeters. That's going to grow that cylinder on top of our box and then merge these 2 solids together. From here, we're going to go ahead and cut this hole out of our part. We're going to remove this cylinder of material. Now the steps for this are going to be pretty much exactly the same as how we created this first cylinder, at least for the sketch of it anyways. We're going to select the top flat surface of this cylinder, create a new sketch, and draw another circle. We're going to use Smart Dimension and set the diameter to 50. Now, since we want to remove this material, we have to use a different tool. If we go to our Features tab and look at our toolbar, we'll notice that it's kind of broken up into boxes. Now, these first two boxes here, they contain similar tools: extrude, revolve, sweeps. The difference is this first tool, this first box here, it adds material. This second box removes material. Anything labeled cut is going to remove that. Anything labeled boss base is going to add material. So we can go ahead and select extruded cut. This tool is going to work pretty similar to how a cookie cutter works. Whatever sketch you draw is going to be your cookie cutter, and the extrude cut tool is going to push it right through your part. Now, by default, the extrude cut tool reverts to what's called a blind cut. What that will do is it will take your sketch and cut it to whatever depth you specify. Since we want this cut to go all the way through our part, we're going to choose another option. We're going to choose the option here called Through All. This is not going to ask us for a depth. Instead, it's just going to take that sketch and cut it all the way through our part. We can go ahead and click OK. And that's going to remove that material for us. So what we can do now is go ahead and save this model. And we can then proceed. Now, when we look back at our finished model, you might be able to tell that the dimensions of this model are slightly larger. What we're going to do is we're going to update our model to reflect those slightly larger dimensions. Instead of 100 by 100 for the footprint of this box, we're going to grow that to 120 by 120. And then instead of 30 millimeters for the height of this box, we're going to grow that to 50. Now, to make changes to our model is pretty simple. If you look at your left-hand side in your feature tree, Solidworks has been keeping track of the work we've been doing. Our extrudes, our cuts, and we can go back into any one of those and edit those values. Boss Extrude 1 is the one we care about right now. If we right-click on that, it's going to give us two options in this little mini toolbar: Edit Feature or Edit Sketch. Edit Sketch allows you to edit anything you set in the 2D Sketch tool. Edit Feature is going to allow you to edit anything you set in the Features tab. Let's first start by growing the footprint of this base. We're going to select the Edit Sketch icon. That's going to bring us all the way back to this 2D sketch that we did. From here, we can double-click on these dimensions and we can set these to 120 each. To get back to our full model, all we have to do is come up here to our top left-hand corner and click Exit Sketch. And that's going to go ahead and grow that footprint. It's going to automatically update that for us. From here, we can then go ahead and grow the height of this box. we're going to come over to Boss Extrude 1 and choose the Edit Feature option. From here, we can change this extrusion height from 30 to 50. We can go ahead and select OK. And that's going to update the height of that box for us. So this looks pretty good. Now when we look back at our finished model, we'll notice that all of these corners have been rounded off. In engineering, we call these rounded corners fillets. And we'll put a fillet on our part for aesthetic reasons, ergonomic reasons. Sometimes it's easier to manufacture parts with rounded corners. To add fillets to our tool, or to our part, we're going to go to our Features tab, and we're going to select the Fillet tool. When we apply a fillet, we have a couple of options. We can come in here and we can select the one individual edge that we want to round over. And Solidworks will round over just that one edge. Or we can come in here and select an entire face. And Solidworks will round over all of the corners attributed to that face. And that's what we're going to do. We're going to select the top face of our box. We're going to check in our items to fillet to make sure that it says face 1. Underneath that, we're going to choose this option here called Full Preview. What that's going to do is generate this yellow mesh and make it easier to see where we've applied a fillet. And then finally, we have to set our fillet size or our fillet radius. We're going to do that right here. And we're going to set that to a radius of 5 millimeters. Obviously, the larger the fillet, the larger that radius will be. Once we've done that, we can go ahead and select OK. And that looks pretty good. So what we're going to do is we're going to do that fillet operation 2 more times. We're going to grab our fillet tool again. This time, we're going to select the top face of this cylinder. Should say face 1 in our items to fillet, so that we're rounding over this interior and exterior corner of that cylinder. We're going to set our fillet radius to 1.5 millimeters. And then we can go ahead and select OK. And then finally, we're going to go ahead and select our fillet tool one last time. This time, we're not going to select a face, but we are going to select these 4 edges of this cube. In our items to fillet, it should read edges 1 through 4. And then we can set our fillet radius to 10. And that's going to go ahead and round over all of the corners on our part. And that looks pretty good. So what we can do at this point is go ahead and save this model, and then we can continue. Now when we look back at our finished piece, the last operation that we do to this is an operation called shelling. And what shelling does is it hollows out your part and leaves behind just a thin shell. You can think of this kind of like taking an M&M, melting all the chocolate out of the inside, leaving behind just a thin candy shell. To do this to our piece, we're going to use the shelling tool. That's located underneath our Features tab, towards the end of the toolbar. This tool applies pretty simply. What we're going to do here is we're going to set our shell thickness. This is how thick our candy coating is on that M&M. We're going to set this to 2 millimeters. Next, we're going to select the surface that we're going to scoop everything out from. We're going to rotate our part to the bottom and select this large flat bottom face of our box. After that, all we have to do is select OK. That's going to scoop out all of the innards of our part, leaving behind just a thin candy shell. And this wall thickness right here, this is that 2 millimeters that we set. So this looks good. And at this point, our model is just about complete. The only thing we have left to do is to set our material. To do that, we're going to come over here to our left-hand side. In our feature tree, we have an option here called Material and then Not Specified. What we're going to do is right-click on that and choose Edit Material. And this is going to pop up with all of the preloaded materials in Solidworks. Our steels, our aluminums, our coppers, plastics. Under the steel folder, towards the bottom, we're going to choose the option called Chrome Stainless Steel. We're going to select Apply, and then we can go ahead and close this window. Now, depending on your laptop, your part will now take on a cosmetic appearance that mimics that material. If you apply carbon fiber, your part will look like carbon fiber. Apply wood, it'll look like wood. And in our case, if you apply chrome, your part will now have a chrome appearance. This is fun and exciting for all of about 30 seconds. And then you guys can quickly see why this is kind of difficult to work with. Because depending on how you have your model oriented, it's either going to white out or black out your entire model due to that reflective chrome. So what I like to do is I like to shut this cosmetic appearance off. To do that, we're going to come up to this View Settings icon. And Real View Graphics is what's going to toggle on and on that cosmetic appearance. When you turn it off, it's going to revert to this sort of dull battleship gray. It's not as attractive, but it's a lot easier to work with. This doesn't affect anything with the material properties. This is just a cosmetic appearance only. So at this point, our model is complete. We've got our material applied. What we're going to do now is check the mass properties of this part. We're going to figure out how much this weighs and the volume of it. To do that, we're going to come up to our Evaluate tab and select Mass Properties. This is going to pop up with our density, our mass, our volume, our surface area. So at this point, our model is complete. If you guys have any questions on this model, please feel free to reach out to me. Otherwise, have a nice day.